Okay, this is the second video of Lecture 6. If you haven't seen the first video for Lecture 6, um, look at that first before you watch this one. That would be better, I think. This is a recorded video, of course, and it's copyrighted, as you can see on the screen. Okay, this topic, or the topic at hand now, deals with templates. Previous video dealt with a class stack, and we will come back to that. We're going to use the class stack as the example for creating a class template. We'll make a templated stack class. Okay, a class template. The template construct is a way to create a generic class. Basically what that's saying is, for example, we could create one class if it's templated, or a template. We could create one class and the array could hold integers. And then with the same class, because it's a template class, the array could hold strings, or the array could hold objects like student objects or box objects or whatever. So in other words, it can hold any kind of object or data type because it's a templated class. So example there, you see it says example, a stack can be a stack of integers or floats or characters, etc., providing that it's a templated class. Okay, well, just real briefly, because you don't even know what it is yet, or maybe you don't. A formal parameter. The formal parameter appears in the class template definition. Actual parameter. The actual parameter to the template is a data type. Any type can be used, either built-in or user-defined. So we haven't really discussed these things, but keep in mind, you guys have probably done vectors and things like that. If you so it's a vector is a templated class. It's something that's done for us. But still, it's so we could create a vector of integers. Come on, Dennis, can't write very well here. I'll just call it numbers. And so a vector is a templated class. And so right here it says actual parameter. The actual parameter to the template is a data type. Well, here it is. There's the actual parameter. It's like a function call in a way. This is the argument that's sent to the template, or to actually the compiler uses to build the appropriate class. So vector int numbers tells the compiler to create a vector object that can hold integers. And of course, as you know, we could change that to string. And now it's it would probably give it a different name too, I assume, cities or something. And so now it's a vector that holds strings, New York and Chicago and Anaheim, whatever. So a vector is all of the standard template library, and notice just the name, standard template library. Those are all templated classes. So they are what we call generic classes. Generic means that we can change the data type, and we just write the class one time, but it allows us then to change. We could change it to float. Okay, here is the class stack that we discussed previously, except now it's been changed to a templated class. Oops, sorry about that. And so over to the right here, I did what we discussed before. Remember that the class stack had two private data members, top and items, which was an array that held integers. Remember, it held a bunch of integers. Okay, well, so now it's the same thing, top and an array, but now look at this. It doesn't say what the data type is. Instead, it doesn't say that it's integers. By the way, the T it's not a reserved word. You can use X or K or whatever you want, but for whatever reason, T has become sort of a de facto standard throughout the world, probably. So I would recommend you use the letter T. And T is just basically it's just specifying that this data type, whatever this is going to be determined at compile time by the compiler. This is a templated array. And so up at the very top, you have to tell the compiler that this class is a template class. And so you have to put this down. You just have to do it. Class T. You got to put that down whenever you do a templated class. By the way, as a side note, just because later you'll go, wait, Dennis, you said that you got to do that. You're allowed to actually, I don't know why you would want to do this, but you can type name T. So if you want to use the word class T, that's great. That's what I do generally. But you can also put type name T. T is the same. So we'll assume we're going to stick with class T. So this tells the compiler then, we put the word template down, no capital letters, class T. This right here, I don't know why I used max items. Usually I use size. Let's pretend like it's size. It's just a constant. You would declare it, I don't know where, maybe up here, const int size. And whatever the size of the array is. Okay. Anyway, so we'll assume it's that the parameter is size. Max items is fine. In fact, I'll tell you what, I may have put max items in here. I don't see it in here anywhere. It's really not necessary. Okay, anyway, so yeah, that's it. Actually, that particular parameter is actually not even needed here. We could have just done, I could have just done this, class T. Because if we simply declared the constant right here, const int size, then we could have used size inside of here, or max item size, and it would not have had to have been passed from main. So this second parameter is not really necessary, but it's in there for right now, so we'll use it. Okay. So we're telling the compiler that this class is a template class, and we do it by saying class T, and this is optional. If you want to put the size in there, that's fine. Okay, and so here you can see that the array is called stack items. In our previous example, we just called it items. Doesn't matter what you call it. But here it's called stack items, and that's fine, no big deal. And then top. And that's what we used previously too. Okay, and then if we continue on here, and by the way then, the T tells the compiler that it's to be determined in main what this will be. Will it be integers? Maybe. Will it be floats, strings? Maybe. It'll determine that later. How does it determine that? Let's go down to main for a second. Here it is, stack. Here it's called int stack. Remember in our original program we went stack, stack. Now it's called int stack. And so it's no big deal, just another name. So let's call it int stack. Whatever you want to call it, you can call it whatever you want. Okay, but look at here. These are called actual parameters, by the way. It's like a function call. These are what are being sent really to the compiler to know what kind of class it is. And remember the first parameter, let's go back up there and take a look. Oops, did I go too far? Yeah, here it is. This first parameter is called T. Wherever there's a T, it's whatever T is. What's T? It's an integer. This is the first parameter. So an int and the size, what's the size? 5. So int and 5 are being sent to here. So this is an int and this is a 5. So wherever there's a T, it'll substitute int. So right here, this is basically saying It's basically saying int. This array is an array of integers. And the size, it's creating an array size 5. That's why I was saying technically if we wanted just to create a constant up here, we wouldn't have to do this from main. We could just do it right in the class itself. So that's pretty much how it works. You specify template class T, and then wherever there's a T, it will substitute in whatever T is, and T is to be determined in main when it's called. So in this particular case, T is an integer. We could create another, we could say stack string cities. And now it's going to send string up there. So it's the data type then would be string. This would be a string. Come on, Dennis. Okay, that's how it works. Okay, looking at this stack class, we're not going to go through all the details again because it's the same thing as before. Constructor is assigned -1, etc., etc. So it's all the same. Make empty, top is assigned -1. So that's fine. But the thing I'd like to point out to you, these are all exactly the same. Notice that top is always an integer. So it wouldn't be t top because the variable top, we want it to always be an integer, and whenever the constructor is called, we always want to assign it -1 to begin with. So top is sort of unaffected by this whole template thing. Top is always an integer. But let's go down to push and pop. See, if this is a templated stack, that means you could use this template to make a stack of integers or a stack of strings or a stack of floats. So whatever t is up at the top, when that's determined that, say for example, t is an integer, then this is int. And that also means then that this is int. And also means that this is int. Okay? But if t is float, then t is float throughout the entire class specification. So down here, this would be float, and this would be float. Okay, well, this is just what we just discussed. Here's the actual parameter. That's the argument, in other words. And it's passed to the formal parameter. And that tells the compiler that t is an integer. So wherever there's a t, it's an int. It's only 3 places right here saying what the array holds integers. And then I've since taken, I didn't finish doing it here, but push and pop have a t in it also, as we saw previously. Okay, and that's fine. But then we could also do stack string. I'll just call it str stack, just to give it a different name. And now the argument is a string. So t is a string. Now it's an array that holds strings. And it pushes strings and it pops strings. So that's how it works. Now here's the thing. The compiler has to look at the declaration and it has to make a complete class specification for integer. So it makes a complete class. I'm not going to do the whole thing, just want to make the point that it does this. Wherever there's a t, but it creates the whole thing. It creates the entire, it does it at compile time. Right at the time that your program is being compiled. Oops, doggone it. The compiler looks at the declarations of the objects in main and builds a whole int stack. And then when it sees that there's another stack object created, and it's a string, it creates a whole nother, class stack. It creates two classes where now it's going to be string items. So in other words, it doesn't actually use the same code. The compiler actually generates an entire int stack and an entire string stack. So if you think about it, you don't really need to use templates, or you don't need to create them yourselves. If you want to, you could just simply create two classes, one called, one called class int stack and one class string stack, and just have two separate classes, and you write your own code, and that might be easier for you to do. But so really all this template stuff, all it really does, a template simply allows you to create one class that's templated and tell the compiler, you generate all the different, if we have a float stack and a double stack, so the compiler will create all of these different classes. But you could do it yourself and not even use templates. I would say for the most part, you probably in your future studies will not create your own templates. There's probably exceptions to that rule, but I know I went all the way to a master's degree and I never found a need to create a template. I did use templates, the standard template library, vector and deck and list and things like that. But those are templates that are already created for us. And of course, they're professionally designed and they're really nice, and we don't have to create any of the functions. We just have to remember how to use them. That's really the power of templates. But you can, if you want to, you can create your own templates and use them. But, I don't know if there's really much of a need for it, because you could just, if you need a couple of different classes, it's probably easier to just simply create those classes, have them be slightly different, give them different names, and do it that way. Okay, well, back to the lecture notes. The bottom part of page 5 is just the main, mains.cpp. Sorry about that. What that's all about. All right. Okay, continuing on here. So this is main.cpp. And so we won't discuss that. You could look through this and see how it's done. I say that, but then let me see here. What do we have here? Here's the declaration for the int stack object. Because it's templated, it's telling the compiler it's going to be a stack of integers. And then let's see if it shows the oops, it doesn't show it. So this is just for the int stack. But of course, if you wanted to, you could create another stack, right here, and just say, stack string or whatever. And, max items, and then string stack. And if you did that, then you would have two stacks, string stack and int stack, and you could use both of them in your program. Okay, so then we'll continue on here then with QADT.